So before talking about JavaScript, I want to quickly go over this, like the kind of the networking side of the of web development. Basically, what happens for a web page to get rendered. So you open your browser, you type in an URL, let's say google.com, and then what happens is your browser sends a request for the Google web page using an HTTP protocol. Uh, and this message flows through your browser to your operating system, and then it goes to like the local router in your house, and that goes to your internet provider. And that message ends up going to Google server, to a Google server store that can be, I don't know where, basically it can be in like different locations in the planet. Uh, but then this server processes your information and it returns to you the HTML, the CSS, and the JavaScript files to run that page. And the flow of this information is it goes through the server, the Google server, your internet provider, and then your local router, your operating system, and then finally your browser. So your browser takes that message and packages it, and then in that package, the browser finds the HTML, CSS, JavaScript, and use that all that information to render the page. So if you take networking, computer networking classes, you will see this in very, 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 like lots of details, how this whole thing works, right? Most of the web pages on the web they use what is called the TCP IP protocol. And inside that TCP IP protocol, we have the HTTP protocol, and it's a whole stack of protocols. And normally these classes go over this whole stack. And if you're interested in the web development or web applications or how the internet works, I encourage you, like strongly encourage you to take a computer networking class. And there is a different, there's different way of running a web page, or actually it's not different. It's just like, I want to highlight that you can also host your page, or you can have a web server running locally in your own computer. So in this case, you have your browser, you type in a URL, and this is a specific URL now. It starts with localhost, and then it has a port number, which is basically an address that you use for your application. Let's say if you're writing messaging service, your service needs some sort of address in your computer, and that address is the port number. In this case, we are using the port 8000. And for example, the mail service, let's say the email service normally has its own port. Every single online service has their own port. For example, when you do SSH from your computer to the Unix timeshare machine on campus, you're using the port 22, which is a reserved port for SSH. And different applications have their different ports. And there are a lot of open ports you can use for custom applications. But basically, when you do that, you start your server and you request, the flow here is a little bit different. So the browser requests the web page via HTTP using URL. So the browser, it's, so the browser doesn't know where the server is. So it's kind of agnostic. So, and the browser just sends the message. But then what happens is, because this is a local server, the message flows through your browser and operating system only. This means that you don't require internet access to run this page, because both the server and the browser are in the same machine. And for example, here I have my own personal laptop. Basically, the message would go to my same inside my operating system. It would be resolved inside the operating system. You wouldn't even use the networking card, and then the message gets returned to the browser, and we get the web page. So it looks very similar, but it's interesting here that no message got sent outside your local computer, not even your local network. You don't even need a router for this to work, right? And this is good, because this is actually how most of the people develop websites. you normally have a copy of your of the server in your local machine. You do your development in your local machine, and then when you're ready to deploy it, you submit this to the server, and then you run and you run the application there, like for production. But this is very good, and I want to show you how to do that because you're going to actually need to do this in this class. Not for the first assignment, but moving, I think, for assignment 2, starting on assignment 2, I think. Assignment 0, I think, don't require it, but maybe assignment 1, and for sure assignment 2, you're going to need to do that. When you start, for example, if you're going to read textures in WebGL, we're going to need to load textures from the server, and it won't work if you try to work it load it directly from the disk. Okay, I said a lot of things, but let me show you how to open a server on your local computer. Okay, there's many ways of doing that. I'm going to show what I think is the easiest. I'm going to open a terminal on the Mac. If you are on Windows or Linux, in Linux systems this is going to be very similar to the Mac. In Windows is going to be so on Windows it would be very similar as well, but the terminal application might be different. So people might use the CMD, the prompt, the CMD command, which is the default terminal on Windows, but you can also use PowerShell. There is also now a whole bash integrated to Windows. But basically, you need access to a terminal where you can type a Python command. And what I'm going to do is, first, I'm going to navigate to the page, to my directory where my website is. And let me get, I think on Mac, I can simply drag and drop it here. And then I'll just CD there. So now I'm actually in the same directory that my file, my HTML, my CSS is. Here we can see the content. Here you can see my directory, right? It's the same files we have. So here, what you can do is you can type Python -m http.server. What this does is -m stands for module. So Python's going to run this module HTTP server here. And if you type Python 3, I guess I have to say. Yeah, because in Python 2 is a different command. But yeah, this is an example for Python 3. Python 2 also has the same module, but the module is named differently. So basically what we see here, I'm going to allow this. We can see here that the result we're giving now, there's a HTTP being served on 0000 port 8000. So this address here is an IP address that has a nickname, and the nickname is localhost. So you don't need to, you can either memorize 0000 or just type localhost. So for example, I can say here localhost 8000, and we get the same page. But now look at if you look at this, I mean, my browser is not showing here, but this is basically an HTTP. Now now there is an HTTP request going through, which is different than when we access it this way. Okay, now this was just with this, the browser was literally just reading the file from the storage system in your computer. And here we are actually, there is kind of a networking stack going on. We are sending a message to the server, and we can see here that the server picked up the messages. For example, we can see the server returning the style.css file, returning the image, you see, and there was a kind of a message file not found here. And this is because we didn't have any favcons in this web page, which means like this tiny thumb, like this kind of tiny icons that we have here. For example, Google has this tiny icon here. This is called like favcon, and every website is expected to have one. This little icon to show on the tab, but we don't have one. So the browser is saying no, the code 404. I didn't find that, and here you say okay. we tried to return this favicon icon, but 404 is a code for not found. Anyways, but the page is rendered, but now through the web server. And this is basically what happened. The same process happens when you connect to Google. There is a server there, and the server works exactly the same way. Of course, this Python server here is a very, very simple server that is not even very optimized, not super fast, but it's the quickest way of getting something up and running. There's other ways. You can start, for example, you could install Apache. Like Apache is a very common open source web server. If you're in Java, you can use Tomcat. So there's all sorts of ways to do that. But we recommend using Python because, as probably you saw, like it's super simple. Just one command, everything's working. Any questions about this? About like opening a server and what a server is and what is the difference between the server and not having the server? So a question here is like, can you repeat what the benefit is of using the server? So there's many benefits. I think the major one is security. You see as you when you're writing, specifically when you start writing JavaScript. JavaScript is a programming language that runs on the browser. And imagine if someone like Google writes a JavaScript file that is kind of malicious and tries to open your computer and access your personal files and stuff, right? You wouldn't want that. Nobody wants that. So JavaScript was designed in a very, like, to be as secure as possible. And the browser itself, there's many things you could do in a normal, like say in C or Python that you'll see you cannot do in JavaScript because of security. So having a server, it's a way to only have access to things that actually the developer wants you to give access to. So for example, when you send a request to the server can retrieve that message and then decide what to serve and what not to serve to you based on some security things. Also, if you're that's before any of that, the web, or this whole idea of pages, they were originally designed to be served through a web server. Why? Because then you can have a web server running in anywhere on Earth, and you can have a browser accessing those pages anywhere you want. So the benefit of the server is pretty much having this distributed system where we can have access to things anywhere, right? For this class, we don't have, for this class or for graphics specifically, having a server and not having a server is not going to make any difference, because this is a class for learning WebGL, right? We are not concerned about, like, we are not very much concerned about security, or we're not, that's not the idea of this class. But as you move to web development, then that thing, so having a server is mandatory. I hope that answers your questions. I don't want to extend myself too much here, but just a side comment on that is that this course is designed using WebGL as opposed to OpenGL, which is the rendering API for let's say C programming language. So you can do that in your operating system, not on the browser. The benefit of using JavaScript and the browser is, first, like, it's easy to set up, much easier to set up and start doing graphics. You just need your browser and a text editor. Those are very simple things most of us already have. And the WebGL is already built in the browser, so you don't have to install the libraries or all of that to start drawing stuff. On top of that, sharing your graphics applications is much easier, because now you are on the web and you can just make a website, put your website available online, and then you have your graphics application available to anyone on the web. So that's why this course is done in WebGL as opposed to OpenGL. But yeah, I hope that answers your question. Let me move forward, and I think we can take a break like in 5 minutes, but let me okay, I just talked about this. So the browser, this is more like how now the browser renders the page. As I mentioned, we have HTML and CSS, and the browser has an HTML parser, which is a piece of software that actually takes those tags and generate images or renders that HTML content. And I think one idea that is important in this slide is that once you parse the HTML information, you get this structure called the DOM, D-O-M. This stands for Document Object Modeling. So it's an object in JavaScript that has this tree-like structure where the HTML tag is the root of the tree, and then all the tags are the children. For example, see that the DOM, you can think of the DOM as the HTML tag, and then you have two children, which are the head and the body, and then the body might have other children, and so on and so forth. So think about the page. It's very useful to think about an HTML page as this tree-like structure that we call the DOM. And if you're reading or studying about HTML, you'll see this all the time, like the DOM. So if you stumble upon this this acronym, you know what it is right now. And similar, CSS does the same thing. It generates a tree-like structure called CSSOM, and those are combined when you want to generate the final web page. Okay, so I think this is a good moment to take a break.